So I'm going to be doing problem number 6 from the chapter 15 homework. So the question says, a molecule of DNA is 2.17 micrometers long. The ends of the molecule become singly ionized, negative on one end, positive on the other. The helical molecule acts like a spring and compresses 1% upon becoming charged. Determine the effective spring constant of the molecule. So I drew the DNA, one end is positive, the other one is negative, and it's 2.17 micrometers long. So then, first we need to find the force, so we can do that by using this equation. Over the distance squared. So then, if we plug in the numbers, you just use the regular K constant. Q1 and Q2, you just use the charges for both ends that's in the book. Or for like electron and a proton. And then the distance is the 2.17 micrometers, but in meters that's 2.17 times 10 to the negative 6 meters squared. And then if you plug all of that in a calculator, then the answer that you will get will be force equals 4.89 times 10 to the negative 17 newtons. And now we need to find the spring constant, so then we use the spring constant equation. Force equals K, which K is the spring constant, times X, which is the distance. So then we know that it compresses by 1%, so we need to multiply the distance K or the distance K, I meant the distance X, times 0.01. And then you get 2.17 times 10 to the negative 8 meters. And then you can plug that into the spring constant and you use that for X, because that's how much it compressed. So then the force is what we originally solved for, 4.89 times 10 to the negative 17. Force equals Kx, or negative, wait no, it's not negative, what am I saying? Okay, Kx 2.17 times 10 to the negative 8 meters. And then you solve for K, and then you solve for K, you get 2.25 times 10 to the negative 9, and that is the spring constant right there. So yeah, this is everything. So yeah, thanks for watching the video, bye.